Okay, so let's review what we studied. You know, in the week before spring break, we studied distributed systems, including client-server, peer-to-peer, and layered architecture. So distributed systems are decomposed into multiple processes that collaborate through the network. So that's the key point. Then nowadays, since we have very powerful computers, we may have multi-cores, then it's possible that distributed systems are also applied to a single node with multiple processors. Then we first studied client-server style. So it is suitable for applications that involve distributed data and processing across individual computers. And do you still remember what are the components in the client-server architecture style? What are the components?
Client and server.
Client and server, right? Then the connectors is the network, which allows clients to access remote servers. Then we studied different kinds of servers. For example, a stateful server, a stateless server, a concurrent server, or an iterative server. Then we studied IPC, which stands for inter-process communications. So our focus is on the message passing because it can be used over a network, but the disadvantage is that it can be slower. Then in order to achieve inter-process communication, we need protocols. So in the last class, we studied sockets, RPC, and distributed objects. So sockets were introduced in 1981 for providing Unix to Unix communication. But now Microsoft also has its own version. It's called WinSock. The socket is very easy to use, and it is a very practical protocol using between client and server. The RPC stands for Remote Procedure Call. So it is a transparent mechanism to give the client procedure the illusion that it is making a direct call on the distant server procedure. The network communication details were hidden by the stops. So stops play a critical role. So basically, we have 10 steps. So stops, both the server stop and the client stop are responsible for parameter marshalling and parameter unmarshalling. So, stop hides all the communication details. Then when you write your program, you don't have to worry about the programming, the network programming details. So this is a very nice procedure. Then distributed objects are all version of RPC. So the server side stuff is called skeleton, and everything is encapsulated in terms of object-oriented. So in your client, you just call the object dot operation. Then the idea is very similar to RPC, but in the server side, still it invokes the operation defined by an object. Then we studied untiered client-server architecture. So the benefits of untiered client-server architecture is that it separates processing to better balance load on different servers, and it is more scalable. The limitation is that it's hard. It puts greater load on the network, and it's hard to program and test. Then, in last class, we studied that we have to encounter legacy applications all the time. And how do you integrate a legacy application into a new application? Do you still remember the solution? For example, you have a very old system. It is a standalone application running on a single computer without network supporting. But now you want to make a web service to your client, and you don't want to redevelop the legacy system now. What is your solution?
And like wrap it in something and make an interface for it.
Okay. Yep. So the idea is that we use wrapper class, right? So the wrapper class is a server class that handles the communication and the management of client requests to legacy application. So, we have two ways. One is through files. So, the communication between the legacy code and your wrapper class is through files. Or the wrapper class can just provide input and intercept output from the legacy class. So then developers can integrate legacy code into a client-server application by placing the wrapper around legacy code. Then, by providing an interface to it, and the wrapper class converts the external requests from clients into calls to the legacy code, and the wrapper also converts outputs from the legacy code into responses to the client. So client server has many advantages. First, the distribution of data is straightforward. Then the location is transparent. For example, Amazon. When you purchase something from Amazon, you don't care where the server is, right? So you just place order. So the location can be transparent. And you can use different platforms. You can use the servers from Dell, Lenovo, whatever company that provides such kind of servers. And the client can be also heterogeneous. And it's easy to add new servers or upgrade existing servers. And it's easy to maintain. And the performance is good because processors can be dedicated to specific tasks. For example, client processor handles the GUI user interface with special purpose graphics hardware. Then the scalability is also good. We can add client at low cost. And we can change servers, transparently. But the disadvantage for client server is that, there's no central register of names and services. Then you can, if you don't have documents, then you can hardly figure out what services are available. Then the server is bottleneck, and the protocol must be compatible between client and server. Otherwise, the client cannot communicate with the server. Then peer-to-peer. So remember that we have two proposals. A peer can be either a client or a server. Proposal 2, a peer can be a client as well as a server. So which one is correct per proposal? Proposal 2. So a peer can be a client as well as a server. Then for proposal 1, if I ask you to draw a class diagram to represent the idea for proposal 1, so a client can be either a client or a peer can be either a client or a server. Then what is your class diagram for this sentence?
Peer is the superclass, and client and server are subclasses.
Very good. So remember that generalization is an OR relationship, right? So then this is a client, this is server, and this is peer. So then peer can be either a client or a server, but not both. So that's proposal 1. Then proposal 2. So a peer can be a client as well as a server. Then what is the corresponding class diagram?
Peer inheritance from both clients.
Okay, so client and server, then peer inherits from both client and server, right? So this is the idea. So this is the design for model 1, and this is design for model 2. Then the correct model is model 2, right? So client is peer is a client as well as a server. The layered architecture. So what is a layer? In layered architecture, what is a layer? So in the future, if you tell your boss that you are going to implement the software system using layered architecture style, then you should know what is a layer. So a layer is a subsystem. So a layer is a subsystem that provides a service to another subsystem with the following restrictions. Do you still remember the 2 restrictions?
Only can access function below the layer.
Okay. So a layer can only get access to the functionality provided by the layers below it, right? Then, what about the other restriction?
It has no knowledge about the higher layers.
Okay, very good. So these are the 2 restrictions. So a layer only depends on services from lower layers. This restriction 1. Then restriction 2, a layer has no knowledge of higher layers. Now, why do we put these two restrictions? What's the reason? Why we require a layer only depends on services from lower layers, and why a layer has no knowledge of higher layers?
Lower the coupling.
To lower the coupling. So that's the idea. So we want to lower the coupling. So the less you know, then the less coupling will help. Okay. So then the layered layered architecture can be classified into 2 types. Then do you still remember the 2 types of the layered architectures?
Open and closed.
Okay, so very good. Open and closed architectures. Then closed architecture is also called opaque layering. It means that each layer can only call operations from the layer below. So layer 3 can only get access to the services provided by layer 2, and layer 2 can only get access to the services provided by layer 1 and so forth. Then what are the advantages for closed architecture?
Low coupling.
Lower coupling, and reusability is good, right? So it minimizes dependencies between layers and reduces impact of change. So it lowers the coupling, so leading to easy maintenance. And the reusability is good, so a layer can be replaced by another as long as the interface is not violated. So then for open architecture, a layer can call operations from any layer below. So this is called indirect addressing. Now what are the advantages for open architecture?
Performance is better.
So it is more efficient. Then what are the disadvantages?
Coupling is high.
Higher coupling, right? So advantage is that it leads to more compact code. As the services of lower layers can be accessed directly. The disadvantage is higher coupling. So the layered systems are hierarchical. So this is a desirable design because we can raise level of abstraction. So hierarchy reduces complexity. And the closed architectures are more portable by providing very low coupling. And the open architectures are more efficient, but it suffers from higher coupling. And what are the components? Layers and connectors can be the protocols, right? And the disadvantages include, not all systems that can be layered, and the performance may not be as good. Okay, so now let's take a look at the example. So we want to create a banking application with customers and related accounts. So an account consists of an account number, a balance, and a credit limit. If the account has been overdrawn, then the account and customer is considered to be sick, otherwise healthy. Then use case 1. As a user, I want to see if a customer is healthy or sick. So, if you see a use case expressed in this way, then you should know that people are using Agile software development, right? So what's the name of the Agile method? Scrum, right? So in Scrum, people model a use case in this way. So as a user, I want to see if a customer is healthy or sick. Then use case 2. As a user, I want to retrieve if a customer is healthy or sick through a web service. So then this is the question. Then what are the entity object and what are the entity control and the boundary? So basically, the problem statement is pretty simple, right? We have a banking application. Then a customer is associated with 0 or more accounts. The account consists of customer number, account number, balance, and a credit limit. Then we want to, the use case, basically 2 use cases are similar. The first one, you just want to see whether a customer is healthy or sick. And the second one is to do the same thing through a web service. Then what are the entity objects? Can you identify entity objects?
Account number.
Account number? Yeah, so the account as a whole can be a good candidate for entity object, right? Then what else? Besides account, we should identify another entity object, which is customer. Yeah. So basically, to model the customer and the account, it is not difficult, right? So for the customer, then we have customer number and the name. Then it has methods such as add account and check whether it's healthy or not. Then for account, it has account number, balance, the credit limit, and we can also check whether account is healthy. So these are the entity objects. Suppose all the data is stored in a database. Then in the first step, you should. How would you establish a customer object or an account object?
I guess you have to fetch the data from the database.
Okay, very good. So in the first step, we should fetch the data from the database. Then we wrap all the data into objects, right? Okay. So basically, we can implement the customer in this way. We have getter setters, and we can add account. Then we check whether the customer is healthy, is to go through iterate through all the accounts. And if one of the account is not healthy, then the customer is not healthy. The account is similar, so we have getter setters. And if the balance is less than the credit limit, then it is not healthy. Then how to obtain these objects? That is to do some fetcher command, implement some fetcher class. So the first one is called customer fetcher DB command, right? So if you provide the customer number, then we can use the cycle clause, such as select star from customer where customer number is equal to the customer number. So then once the data is read, then you will assemble a customer object, then return the customer. So this is the customer fetcher DB. Then correspondingly, we should also have another fetcher class for accounts, right? So we call it as account list fetcher DB command. So still based on the customer number, we retrieve a list of accounts. Then we, for each account, we assemble the account object, then add account to the list. Then we return the list. Okay, so now we can retrieve a customer and a list of accounts associated with the customer. And in the next step, what should we do?
Get data from DB command.
Okay, so since we can retrieve the data, then we should assemble a complete customer. So for this customer, it only has the customer number, name, but it doesn't have the list of accounts. And this one has a list of accounts, but it doesn't have the customer information, right? Then we should combine the output from both classes. So then we call it customer builder service. So we want to build a complete customer. So in the first step, we call customer fetcher DB command to create a customer object. Then the second line of code is using the account list fetcher DB command to retrieve the list of accounts. Then we iterate through the account and add the account to the accounts to the customer. Then we have a complete customer, right? Okay. So now we can check whether a customer is healthy or not. So use case one to show the result to a user. Then we create another class called customer status controller. So this is a controller object. So first, by providing the ID, we can get a complete customer. So customer builder service is responsible for returning a complete customer object. Then we can check whether the customer is healthy. So if it is healthy, then we label it as healthy. Otherwise, we label it as sick. So this use case one. Then for use case two, we can do it similarly, right? So use case two is a web service. So this class implements the iService interface. Then we check is customer healthy. Still, we call customer builder service to build a customer. Then we return whether the customer is healthy or not. Okay, so now let's see. In software engineering 1, we studied that the architectural components include data storage, data access logic, and application logic, and presentation logic, right? Okay, then back to our example. So the data storage is in the database. Then how would how did we retrieve the data from database?
Fetch DB command.
So we defined fetcher, right? Customer fetcher DB command and account list fetcher DB command. Then based on this command, how did we build a customer?
Call customer fetch DB command and account list DB command.
So then in that case, we used the customer builder service, right? To build, to get the customer and the account objects. Then how did we satisfy the two use cases?
Services.
So then we use customer status controller and the service, which is built upon the customer builder services, right? And if we put them together, what is this? What kind of architectural style is this?
Layer.
It's layered architecture style. So the customer fetcher DB command and account list fetcher DB command are only responsible for retrieving data from the database, right? So it makes both classes make no assumptions about what classes will make use of them, right? Then the customer builder service will be built upon these two fetcher classes to build a complete customer object. Then the two use cases are built upon the customer builder service to enjoy all the services provided by lower layer. So is that clear for this part? Okay, then is this closed architecture or open architecture?
Close.
So this is closed because customer status controller doesn't access any of the services provided by fetcher commands. So this is the idea of layered architecture. So it provides a lot of flexibility and it can solve many practical problems. So in the future, if your boss asks you to make a design, then this is going to be a very good example, right? So you can immediately provide a very professional solution, by providing the first layer, that is the fetcher DB command. Then the builder services are built upon the fetcher commands. Then all the use cases will be satisfied by this layer. Okay, so do you have any questions for what we discussed today? All right, so keep in mind that our second group assignment is due on Sunday. Then you should provide the performance comparison, between your first implementation and the second implementation. So even though you use all architecture style, you are not encouraged to duplicate data. So you still follow the idea of shared data, but you encapsulate all the data structures by providing the interface. So that's the idea. Okay. So that's all I have today. Thank you.